Day 2 of section 12.2, and today we are subtracting polynomials both vertically and horizontally. So when we subtract, we know, we've discussed a lot this year, we actually consider that to be adding the opposite, right? And so we can see that this 4-term polynomial, we are subtracting a trinomial from it. So there's one trinomial here, and so we can make that one visible, and then we can add the opposite. That's the same as subtraction. So we'll distribute that negative to each term in the group. So this is really important. So we have the opposite of 3k cubed, so we're going to subtract 3k cubed, or we're going to add a negative 3k cubed. We're going to add a negative of 5k, so we're going to add negative 5k. And I'm going to line that up vertically underneath the 1k in the 4-term polynomial. Finally, we're going to add the opposite of the negative 2. So if you see subtraction, you could change it to adding the opposite there as well, right? So when I multiply negative 1 to the negative 2, I end up with a positive 2. So I'm going to basically be adding 2. So now we have all of the like terms in columns, so we can simply add. 6k cubed plus negative 3k cubed is 3k cubed. Negative 2k squared has no k squareds to add to it, so we're just going to bring it down, right? 1k plus a negative 5k is negative 4k. And negative 9 plus 2 is negative 7. So here we have our 4-term polynomial. Let's try it again with number 5. Now, the best thing you could do is pause the video, try the problem, come back and check your work. Okay, if you're back, let's walk through this. We have one trinomial that we are subtracting from another trinomial. So we could call this adding the opposite of this entire trinomial, right? And so we can write adding a negative of r squared. The invisible coefficient there is 1, right? So I have negative 1 r squared. Then I'm going to add the opposite of 6r. So I'm going to add negative 6r. I can write that as plus a negative 6r or just minus 6r. And finally, negative 1 times negative 1. Remember, where there's subtraction, you can change it to adding the opposite. So I have two negatives, so negative 1 times negative 1 is positive 1. So here we are. We have 4r squared plus a negative 1r squared, so 3r squared. Where there's an invisible coefficient, we can make it visible. We can also add the opposite here, right? So I have negative 1r and a negative 6r. So that means I have negative 7r's. They both have the same sign. So we simply add their absolute value, right? 8 plus 1 is 9. So here is the resulting sum. Once again, we're going to subtract a polynomial from another. And this time, I think we're going to walk through this horizontally. So you could pause the video, write it down, and maybe see what you could do horizontally. Come back and try. Okay, so again, I have, wherever I see subtraction, I can go in and add the opposite, right? And there's one binomial here, so I'm going to add the opposite of the entire binomial, which means I'm going to distribute negative 1 to both terms, which means I could literally say I'm adding the opposite and opposite. So now I end up with an addition expression, right? So we start on the left and we see 6m squared. Are there any other m squareds? Negative 7m squared. So 6m squared plus negative 7m squared is negative 1m squared. And the 1 can be invisible. I look next at 2m. Are there any other terms with just an m with a 1 exponent? And I don't see any. So I'm just going to bring down the 2m. Check that off. And now I see a negative 3 plus a negative 4. So we end up with a negative 7. So the resultant sum is negative m squared plus 2m minus 7. Okay, one more time. Why don't you again try this horizontally, leaving them where they're at, but changing all subtraction to adding the opposite. Come back when you're ready. Okay, so I'm going to start over here where I see subtraction of 3. I'm going to add a negative 3, right? Where I see subtracting a whole 1, this whole binomial, I'm going to add the opposite of each term. So I'm going to say negative 1 times negative 2x squared is a positive. I'm going to add the opposite, right? And negative 1 times 1x is a negative 1x. So I just changed each of their signs to their opposite. That's what we do when we're subtracting. So now let's look and gather like terms. 9x squared plus 2x squared is 11x squared. And I like to check them off to make sure I've covered every term, right? 4x and a negative 1x is 3x. Good. And then I have negative 3 and no other term to add, so I can just plot down negative 3, which is the same as adding a negative 3. And there we have it, 11x squared plus 3x minus 3. So to top it off, we're going to look at this interesting geometry problem. We have a treehouse, floor of a treehouse. And so in order to get into the treehouse, if you have a floor, sometimes a ladder leads up to a hole in the bottom of the treehouse. And that's what we have here. So the whole treehouse floor is 8x by 5x, right? And then there's a hole cut into it with this, and the hole's area equals 2x squared plus x. So how do we write a polynomial expression for the area of the treehouse floor? So the floor is this entire rectangle, but we have to take away this. So if you recall, I called this kind of a problem a donut problem because we have a big rectangle donut and then we're cutting out this little rectangle hole in the floor. Okay, so how do we find the area of a rectangle? Let's recall. Area of a rectangle. Area, some of you say length times width. In geometry, we typically say base times height, right? But in this case, the area will be the base times height, and then we're going to subtract the whole, right? So let's see. The total area is base. So think about this rectangle. We could call 8x the base and 5x the height, right? So we have 8x times 5x. And then we're going to subtract this whole, which they gave us the area for, 2x squared plus x. Okay, I had to kind of scoot the expression over a bit. So we're going to subtract 2x squared plus x. And excuse my writing, it's kind of hard to write on this computer screen. So there we go. So let's simplify now. So the total area equals 8x times 5x. So 8 times 5 is 40, and x times x, 2 factors of x. So we have 40x squared minus 2x squared plus x. So that's what brings us to today's topic, subtracting a binomial, right? So let's use the same strategy we used earlier. So we have one binomial. We're going to add the opposite of each of these two terms, right? Which means we have 40x squared plus the opposite of 2x squared, so negative 2x squared. Now remember, there's a 1 in front of that x, right? Where there's an invisible coefficient, there's a coefficient of 1. So I have negative 1 times 1x, so negative 1x. This negative 1 times a positive 1x is negative 1x. So let's combine like terms. And I can see the x squared terms, second degree terms. So we end up 40x squared minus 2x squared is 38x squared plus a negative 1x. which can also be written as minus 1x or just minus x. So here is our polynomial expression, simplified expression for the tree house floor. And you're ready to go to work with your subtraction of polynomials. Have a great day.